Hello! We've talked before about margin of error being the critical value times the standard of error. And now to be a little bit more specific about it, here are all of the formulas for margin of error. So you take your z star times your standard error for one sample, t if you don't know the population standard deviation. Always take your z star times your proportion. For two sample t, you got t times that, z star times your proportion. The one we haven't talked about so far is a linear regression t, where we take our t star times our standard error of our slope. Now, in doing so, we should know that the margin of error is always how far the confidence interval strays from our point estimate. So our point estimate being x bar or p hat, or sometimes could be one mean minus the other mean, or it could be, slope, could be one proportion minus another portion. All of these would be our point estimate. And now our margin of error tells us how far we stray from that to estimate our mean at a particular value. Now, if we want a particular margin of error, we could figure out what sample size needed for that margin of error. I'm going to go through two examples with mean and then do a proportion one on the next video. Here's one. It says researchers would like to estimate the mean cholesterol level of a particular variety of monkey that is used in laboratory experiments. They would like to estimate the estimate to be within 1 milligram per deciliter of blood of the true value of mean mu for 95% confidence level. In a previous study involving a variety of monkey suggested the standard deviation for that set of monkeys is about 5 milligrams per deciliter. Find the minimum number of monkeys needed. Well, we know that we want the margin of error to be within 1 milligrams. So that's where we want our margin of error. We know we want a 95% confidence level, and our sigma is 5. Now, if our margin of error is less than this, our margin of error is our z star, since I know my population standard deviation, times sigma over the square root of n. That has to be less than 1. Now, we have to find our z star for a 95% confidence interval, which is 1.96. Multiply it by our standard deviation, 5, over the square root of n. Now, we just have to solve this for n. This is a little tricky for some folks. You multiply 1.96 times 5. That gives us 9.8 over the square root of n. And now I multiply it by the square root of n. And now I have to square 9.8 to get that out of the parentheses. So our number has to be more than 96.04 to be less than 1. So we have to pick the number right above that. So we need at least 97 monkeys for this one. All right. Now let's do one more. Suppose we want to estimate the SAT score for 385,000 high school seniors. If you gave a test and the mean was 461 with our standard deviation of our sample being 93, how large would our sample have to be to get an estimate within 5 points at a 99% confidence interval? So our margin of error has to be less than 5. Now we have our sample standard deviation, so we'll have to use our t star times s over the square root of n. That has to be less than 5. Now our t star, using our 99% confidence interval and our value. Now we'll look at 99% confidence level on this chart. And 99% confidence level is over here. So since that's over here, we'll look at these values. And I would expect it to be a pretty high number. So let's say that n is between 100 and 1,000. We'll use this for our t star, 2.626. So we have 2.626. Our standard deviation is 93 over the square root of n. So now we multiply 2.626 times 93. That's 244.218. Now I multiply by the square root of n. So it's 5 times the square root of n. Now I divide by 5 to get 48.8 is the square root of n. And then when I square that, I get 2,385.7. And so since this has to be greater than that, I'd say 2,386 people. So that's about how many people you would need in order to get our standard deviation less than 5. All right, our next example will be proportions in the next video.